Hello, my name is Blanca, and today we're going to discuss the research question of what factors explain the differences in company sales in different years. So we have two variables, company sales and industry sales, and we see that we have 20 observations for each, so 20 years. And first previously we had to transform these nominal values to real values so that we can work with them. Then we have their mean, their standard deviation, their minimum, and their maximum. So we have that our Y variable will be company sales and our X variable will be industry sales. First of all, we had to see if we need a dynamic model or a static model. A dynamic model is basically using variables from the past to help me understand the present. So we will see with the parallelograms if we need any lags. So for company sales, we ran the lag and we see that the PAC for period one is 0.7119, which is higher than 0.5, and therefore we will introduce a lag in company sales. For the industry sales, we also ran the parallelogram and we saw that the PAC in period one is also higher than 0.5. It's 0.7229, which means that we will also add a lag. So we will have company sales T minus 1, and industry sales T minus 1. So here we have our regression, our dynamic regression, and we have these coefficients that we can see that are all relevant because they have 3 asterisks, and therefore their p-values are not only lower than 0.05, but also lower than 0.01, which is very good. So first of all, we can see that a 1 year increase in industry sales over time is associated with a 0.160 increase in company sales over time, on average, holding all else constant. Then we have that a 1 year increase in company sales in period T minus 1 is associated over time, is associated with a 0.853 increase in company sales over time, on average, holding all else constant. And finally, we have that a 1 year increase in industry sales in period T minus 1 over time is associated with a decrease of 0.138 units of company sales, a decrease in company sales over time on average, holding all else constant. Then the variable here, constant, is not relevant. It's just a mathematical number. Then we have that our adjusted R squared is 0.989, which is very good because it means that our regression explains 98.9% of the changes in company sales. We had to test for zero correlation and spurious correlation. So for zero correlation, we had to run the Durbin's alternative test and the Bush-Godfrey LM test because it is dynamic and only these two are appropriate for dynamic models. So we had that both tests gave us a p-value higher than 0.05, and therefore we have to accept the null hypothesis, which is that there is no zero correlation, so very good. And then for the second, for spurious correlation, we had to run the Dickey-Fuller stationarity test on every variable, so every x and y variable, and the test gave us a value of 0.2860 for company sales and 0.1975 for industry sales. So we accept the null as they are both higher than 0.05, and we can see that both variables are non-stationary. This means that the coefficients are incorrect and that their standard errors are too small. So because of this, we have to change our whole regression. So instead of the original values, we will have to add growth rates. So instead of y, the changes of y, and instead of x, the changes in x. And this means that our whole interpretation of the regression changes and is now what can explain if we have bigger or smaller jumps in company sales over time. Thank you very much.